Hi, I'm just going to take a moment to tell you that all the programs I discuss in the video have links in the description below, which you could click and practice for yourself. And don't forget to subscribe if you haven't done so already. We start with iterative programming or loops, and we're going to cover the topics iteration, while loop, break and continue in while loops, infinite loops, range function, for loops, break and continue in for loops, and nested for loops. So what is iteration? It's a statement that will repeatedly execute either a single statement or a group of statements as long as the condition is true. We're going to look at two loops. There's the while loop and the for loop. The while loop is called the conditional loop, and since the number of iterations here may or may not be fixed, it allows you more flexibility. You could have fixed conditions like while less than 10, or you could have a Boolean condition like while true. You can also use while in a program where you're writing a game and you want the game to stop when the user presses a certain key. The for loop is called a counting loop since it's more fixed in its construct. It allows you to run the loop when you know how many times or exactly the number of times you want to run this. Now let's look at the syntax of the while loop. Now the while loop would start with some input statements or initializing statement, and then you could have the while keyword followed by test expression and some statements within the loop. You could also have an increment or a decrement counter if needed. You move out of the loop when the test expression is false. We start with an example of while loop. We initialize a variable x as 0, and we take the keyword while to start our while loop, where we check a condition x less than 0. We have these two statements within the while loop, and it will print the value of x each time. The moment x is equal to 5, it will now print what is given in the else statement. So let us execute and see the output. The output shows the value of x is 0, 1, 2, 3, and 4. And then the else statement gets executed. In the end, the output statement given outside the loop is printed. We are now going to look at an example of a while true loop where we take a user input, store it in this variable key underscore input. We also have another variable play to which we've assigned the Boolean true, and this true we've used with while. We say that while this play variable is true, print the game is on, and then check the variable key underscore input. If it is equal to Q, then assign false to play, and the moment that assignment happens, the while loop will stop and print the game is over. So we have taken the input as Q. If we execute this program, it will give the output as the game is over. We can also use two special statements called break and continue to change the course of a normal while loop. Let us look at the while loop with a break statement. We have the keyword while followed by test expression 1. The statements within the while loop will continue. Each time an if statement will check test expression 2, and whenever this is true, the loop will break. If it is false, the next repetition of the while loop will follow. We look at an example of while loop with a break statement. We start by initializing z equal to 10, and in the while loop, we check whether z is greater than 0. If it is, then we print the value of z and decrement z. We also check with an if statement whether z is equal to 5, and if that is true, the loop should break. When we execute this, we'll see that the output shows the values 10 to 6, and the moment the value of z is 5, the loop has stopped. Let us look at the syntax of while loop with continue. Here we have the while keyword followed by test expression 1. We have the while statements within the loop, and then we have an if condition to check test expression 2. Whenever this is true, the loop will ignore the code in the current iteration and continue to the next repetition of the loop. We look at an example of a while continue loop where we've initialized a variable num equal to 10 and we check the condition num less than 40. We print the value of num and we increment it by 2 each time. Now we will check if num equal to 20, then it should continue. And we execute this, we get the output starting from 10 to 38, but 20 will be missing. Iterations can also end up as infinite loops if the semantics of the program are not correct. Let's look at this with an example. We have x equal to 5. We are checking while x greater than 0. We print x and then we say x plus equal to 1, which means that x is going to get incremented every time and it's always going to remain more than 0. Now, in this case, the output will be infinite. To make this into a finite loop, we just have to change x plus equal to 1 to x minus equal to 1. Now the semantics of this program will allow it to become a finite loop, which is decreasing value of x till it becomes equal to 0. And then this loop will stop. We now introduce range, which is a very versatile function and can be used to generate a sequence of numbers. To define range, we can give within the brackets 1, 2, or 3 parameters. So starting with the first one, we have range n, single parameter. It returns 0 to n minus 1 numbers. Range x, n will start from x, increment x each time by 1 and end at n minus 1. Range x, n, z starts with x, increments x by z each time and ends at n minus 1. The for loop has a syntax using two keywords, for and in. For is followed by any variable. In is followed by a sequence, and then we have the colon followed by a group of statements within the for loop. Now, the sequence could be either generated by range, or it could be a string, list, tuple, or dictionary. We'll be doing these in our examples. Let's look at the range function, which gives us a sequence of numbers. However, if we use print and give the range, it will not give us a sequence of numbers. Instead, it will give us this output. In order to generate a sequence of numbers, we have to explicitly typecast it as a list. The 3 numbers in the bracket after range are for the initial value, the final value, and the step size. In case we give a range from 0 to 10 and the step size 1, the output will always start with 0 but go up to 1 less than the last number, that is 9, because the range always gives n minus 1. Now here we have 2 as our initial value, 20 as the last value, and 2 as the step size. So the output will be 2 to 18 because the last value 20 will not be output. Similarly, if we give just 2 and 5, which is also okay because by default, it will take the step size as 1. So it will generate 2, 3, and 4 as the output. If we write range 10, it will take the step size as 1 and the initial value as 0. So it will generate numbers from 0 to 9. We can use the range function with the for loop by using the keyword for in and then giving the range. So for and a variable and then in and then we give the range. If we give an output statement in the for loop, we will be getting the numbers from 1 to 19 and the step size is 2. So it will generate a sequence of odd numbers. And similarly, if we give the range as 0 to 22 and step size as 2, it will generate even numbers from 0 to 20. We look at some more examples of for loop, and this time we're going to use it to read a string, a list, and a tuple. So we start with a string iteration, and we use the variable x, the keywords for and in to read iteration. So when we print x, it will give us an output where it's reading each letter of the string and printing it on a new line. If we want it to be printed in the same line, we can use the parameter n, put it equal to an empty string. Then the output will look like this. If I put a space in this string, then it will output a string with a space between each letter. Similarly, we can use a for loop to read a list of numbers and print it. So here is the output. If I use it to read a tuple, and this time I'm using the parameter end and I'm giving it a single space, now it will output it in the same line. All numbers come together with a single space between them. For loops can also be used to find the sum and product of a range of numbers. We're going to take two examples here. First, to find the sum of the 10 natural numbers and to find the product of the first 10 odd numbers. We start with the variable sum, put it equal to 0, and we use the variable x in a for loop to read values from 1 to 10. Each time it will add it to the sum. Once the for loop is over, it will print the sum as output. In the product, we take a variable prod, put it equal to 1, and we use the variable odd underscore num, which will take the values from 1 to 19. Since the step size is 2, it will be generating odd numbers 1, 3, 5, 7, so on. And each time, odd underscore num will multiply that value to the old product. So after the for loop is over, prod is going to give us the product of the first 10 odd numbers. So here's the sum of the first 10 natural numbers and the product of the first 10 odd numbers. The break statement within a for loop will terminate the statement wherever the if condition is true. The continue statement in the for loop will check an if condition within the loop, and when that is true, it will ignore the code for the current iteration and continue with the next iteration. Just like we did in the while loops, we are also going to use the break and continue statements with for loops. Here we have two examples. The first one is demonstrating the break statement. The second one, the continue statement. In our first example, we have a for loop where x takes the values from 0 to 9. And if the value of x is 4, the loop will break. In the second example, we use a variable z in the for loop, which reads the values from 0 to 9. If z is equal to 4, it will ignore 4 and continue the loop. Let us execute this. In the output, we see that the moment x is equal to 4, the loop has stopped. The output for the continue example shows that the output does not have the value 4. It has ignored that and moved on to 5, 6, 7, and 8. In a nested for loop, we have two loops, that is one loop within the other. The outer loop will take on the first iteration and the inner loop will complete the entire sequence of iterations till it moves out to the next iteration of the outer loop. We will see this more clearly in an example. Let us look at 3 examples of nested for loops. We start with the first one where the outer loop has a variable x which takes values 1 to 4, an inner loop which has y which takes values from 1 to 10, but since it's generating odd numbers because of the step size 2, it's going to take values 1, 3, 5, 7, and 9. Now, if we run this loop, we have 2 output statements for each iteration. So each time it is going to give the value of x, and the complete loop of y will show up as values. So here we have the value of x is 1, whereas it's showing all the values of y. Similarly, the value of x becomes 2. It shows all the values of y. Each time x changes its values, y will show the complete iteration. Let's look at the second example. In this, x again takes the values 1 to 4, but here the values of y are given in the list. So every time the value of x is going to be output, all the values of y will be output. The entire list is displayed each time. We look at the third example where we have used a list to generate the values of x, but we have the values of y from range 1 to x plus 1. So y will take the values 1 to x. So let's look at the output. The first time the value of x is 5, the value of y is 1 to 5. The next time x becomes 10, the values of y are also 1 to 10. The third time the value of x becomes 15, y will generate values from 1 to 15. So we've seen how nested for loops can manipulate data in many ways. We will be using this knowledge in the coming chapters. I hope you got the picture. Now, if you haven't understood all the programs, you can always click on the link in the description below. And I hope to see you soon.